The floor is yours.
What you heard at the beginning, that there is a big list of participants here. We were the last ones in the row. We are the researchers and the educators, according to Flora Rétfalvi. And last week, it's common knowledge, but last week I realized when I was on the Hungarian-Swedish soccer game that it's true that Hungary is the 10 million experts of soccer. Everybody understood what to do. But we all know that in Hungary, everybody is an expert of politics. Everybody is an expert of health. And here, in this room, everybody thinks that we are experts of education. So when we talk about education, Annika pointed out that we need goals. So when you talk about the goals of education, then you enjoy or you are happy if your kids have good grades. Maybe they write good midterms. Sometimes they might like a teacher and you remember always for your favorite teacher. Occasionally, knowledge comes to the picture. When it comes to knowledge, probably you assess pupils and students only on these midterms or in exams, and you are happy with the grades, but still, you like if your kids or students are motivated. This motivation is not an excellent word for school, because you are motivated either because your parents are sending there, either because your teacher wants you to have a good grade. So when you go for the educational part that we would like to achieve, it's more like about having some new skills, having some competencies, achieving knowledge. And just again, referring back to Annika, we need clear goals. So our research group is working now for about 10 years, and we figured out that we need 3 kinds of main goals. These main goals are being engaged with the topic. Engagement is much stronger than motivation. Engagement is when you would like to do it. By the way, on the personal side, Vilmos just mentioned, how are your kids today? Thanks. So our main goal is to achieve long-term knowledge. Our main goal is to achieve and develop problem-solving skills. And when you are for this, everybody has some memories how he collected them. So we would like to do it in an effective way. What do we mean by an effective way? It should be effective in time. So achieve long-term knowledge and problem-solving skills and several other competencies in the shortest time for the students, and cost-effective in the sense, from the point of view of the teacher, how much energy she should put in. So we need another point where we would like to start with. So when you are talking about education and teaching and learning, you go for, thanks Irina, you go from several aspects. We are assuming in our research that the place of learning and thinking is the brain and nothing else.
And memory is connected to brain. So we know that memory has 3 main functions. These are encoding, storing, and retrieval. But what these old-fashioned pictures here? Because with the development of digital tools, we rather associate these ones. And parallelly with this change, our knowledge about memory has changed a lot as well. And today I will talk about the big role of retrieval, and we should consider it like a necessary tool for long-term knowledge. And without it, our students will unable to learning. So here I introduce a basic experiment in connection with retrieval. The participants were divided into 2 groups, and at the beginning everybody had to read a long text, and they knew that they had to memorize as many as they can. And after it, the control group had to read this long text 3 times, while the experimental group couldn't read it anymore, but they were tested 3 times. from the read content. And maybe it's not a big surprise that at the end, okay, there was a little rest. I think that they played Tetris, and after it, everybody were tested from the content. And maybe it's not a big surprise that the control group, so the reader group, performed better. But the researchers were curious that what is the long-term effect of retrieval, or the testing effect. And we can see the result here from two aspects. Firstly, on one hand, we can see that the experimental group performed much better than the control group. But we can see, from another side, that the control group, the reader group, forgot more than the double as they originally memorized from the text. And it's a huge forgetting rate. And if we see the experimental group, this forgetting rate is much less. So it was a bomb among cognitive psychologists and educational researchers, and they repeated this experiment in several ways, and they variated it. Mostly they variated the type of testing. For example, they used multiple choice testing or essays, and it revealed that the big question is not how we test, but the big question is to do or not to do, because it revealed that testing is the cause the big differences in the results. So it's really important, and we know now, today that we have to change the famous Hungarian sentence, because retrieval is the mother of knowledge. And these three main functions, that encoding, storing, and retrieval, it's a really complex process, and now we know that it's not a linear process. For example, if we would like to encode anything, during this process we have to retrieve as well. So somehow in mathematical language, retrieval is part of encoding. And we say that we retrieve something if we strengthen our brain, so we can't copy it from a book or something. And if it's successful, a biologist researcher says that it leaves a chemical trace in our brain as well. And we were among the first in the world who investigated this effect in the mathematics education. It wasn't really an easy question, because earlier they investigated it in foreign languages and memorization areas. And mathematics is a little... somebody says that mathematics needs a little other brain. So it was a really big challenge for us. And firstly, we investigated it in high school, and we showed that it can increase long-term knowledge, and underprivileged students could catch up to high-performing students from really elite high schools. So it was really good for them as well. And after following these experiments at tertiary education, we focused on three main problems of universities. The first, the students' exam memory. And exam memory is not the fourth type of memory functions, but exam memory is a well-known symptom, which means that students forget almost everything after an exam. The second problem of universities is the high value of dropout rate, and we know that those students who arrive at universities with stronger input knowledge, usually they are the successful university students, and it's not good for weaker students who would like to catch up. But all of these problems, retrieval practice was a significant method.
So when we talk about knowledge, We would like to distinguish several kinds of knowledges, and now I would like to show you an experiment, because what was the problem? The problem was that when we had these after-class tests, because you have to test pupils after every single class for 5 minutes, but you have to test students. And when they failed in this test, which was usually solving a mathematical problem, writing it down, it required lots of grading from the teachers, much of extra effort. So the question was, can you save this extra effort? So now I would like to show you briefly, you can't hear me this way? Okay, so I would like to show you briefly an experiment which was done at EduTUS University in a teacher training program, and it involved the whole 80 students there, and we were training them for problem-solving skills. And our hypothesis was that, hey, it jumped too much. Okay, so it was jumping 3 slides when I pushed it, sorry. So this is when I talk about knowledge. So knowledge, what kind of knowledge do you have? Lots of knowledge are the so-called lexical knowledge, when you have some information, when you give back some words, when you give back some... But there are the other kind of knowledge, the so-called tacit knowledge, when you apply your knowledge, when you combine them, you do it during problem solving, especially with medium or more difficult problems, when you don't get the answer in one step, but you have to go to different ways. So teaching problem solving is difficult, and that's our goal. When you go to the other way, when you are just know something which is very important, lexical knowledge, it's a different kind of knowledge. Also, how do you test knowledge? Usually, when you test knowledge, either you have a quiz, a multiple choice questions, or you have the long answer kind of. So when you ask for analytical knowledge, then the expectation is that you have to teach them and test them on an analytical way, which means that you have to, the teacher has to see, the assessment person has to see how people think, how people work, and kind of at this point, we cannot really do it on a computer-based assessment system. So our question was that, can you teach problem solving? Can you teach mathematics on such a way that at the end they obtain analytical knowledge, but you test them on a multiple choice way? And as I told you, we had an experiment with teacher training students. They were mathematics students at our university, and our hypothesis was that those students who are trained with solving always long answer questions on the tests will perform later better than those who do just multiple choice answers, which is bad from the point of view of digital education. And the question was, so we split the class into 2 parts. Half of them had to write after every class a short quiz right after class, and half of them was allowed to take home. So altogether we had 4 groups. Each of them were divided into 2 parts to eliminate a little bit the teacher's effect. So 2 of the groups were taking home the problem and doing it at home. 2 of the groups were writing in class in the last 5 minutes of the class. Then half of each group had to write a long answer question, had to solve a problem on paper or on tablet and pencil, and the other half got a multiple choice question, just clicking fast on their laptop or on their phone. And surprisingly, okay, this is just because we have a PPT, and the PPT is not unique on every Windows system, so the circle was around the 38%. So the at-home long answer group produced pretty badly, but all other groups proved similar skills on the first and second midterms. And also, we had a post-test, which was 3 months later than the original test. So what you can see is that there is some, these are just averages, but if you look at the box plot, you can see that the distribution is everywhere the same, except in the third, there are very few dots. So those who were taking home and writing at home the long answer questions were dropped out. from the course at halftime. All others produced very similarly. So surprisingly enough, we could say that those who take home and write at home, kind of as a homework but the same day, produced in a worse way, but multiple choice answers and long answers produced the same kind of effect, which is a good direction to make easier teachers' work and do the computer-based evaluation of teaching problem-solving skills. Thank you.